Here are our session objectives. What I would be like to cover in this session is what are all the default user accounts we get with Netezza setup, followed by high availability, followed by NZSQL introduction. Whenever I buy a Netezza box, I get these three default accounts. Of course, there are other database user accounts or platform level user accounts, but these are all the three notable ones. One is NG, another one is admin, third one is root. Root is Linux super user which provides system root login. Now we were talking about yesterday, right? And in the previous classes, Netezza is combination of both hardware and software, right? Root takes care of entire system. Root is capable to take care of entire system. When I talk about NG, this is a Linux user, and it is only Netezza super user. For example, if you want to upgrade Netezza software from 7.2 to 7.3, let's say tomorrow, NG will take care of it. If you look at, you logged in as an NG user, right? And the third one is admin. Admin is a database level super user. Let's say you want to create a new database, or you want to give someone a privilege to connect to it. So then you look into admin. If you look at in the brackets, whatever we have, these are all the default passwords. NG has a default password as NG. Admin has a default password as password. Root has a default password of hostname. The default hostname is Netezza. That's why I kept in brackets it as Netezza here. These are all the defaults, right? But Netezza highly recommends you, once you buy the box, the guy will give you the setup. Whoever the guy did the setup will give you these default user accounts, and it the Netezza guy will ask you to modify the passwords ASAP, as soon as possible. But these are all the user IDs, passwords we can use it in our emulator. If I can show you that once. So here we are using NZ and NZ, right? So when I say host name, the default host name I get is Netezza. So and it is the password for root as well. When I say switch user to root, when I say this, I will log in as a root here. Admin I'll just talk about in the second half of this class. When we are trying to connect to database interface, that's when we use this admin. And another important thing to know is what are all the default file systems we get, right? Again, Netezza is highly customized for data warehousing, right? When I buy the box, I buy with various specifications saying that these many disks I get, these many hosts I get, these many processors I get, this is my host memory, right? And all that information, along with that, when I say df-k or df-h, it will show me the list of file systems that's available in host box. We are on host system right now. We are on host box right now. On the host, in real time, you'll see these are all the various file systems and the place where they mounted on. Out of these file systems, till here it is fixed. And Netezza recommends you not to alter this file system, not to extend or not to shrink, right? If you want to use any of these file systems, it also recommends not to have your own file system. For example, we take backups into a separate file system called mode backup, right? Out of these given file systems, whichever I highlighted in bold here, these are all the file systems very important for Netezza operation. Netezza operation as in Netezza software and database. I mean the other file systems are also very important, but these are all for root, opt, temp, var. These are all mostly fixed. But these two here, export, home and ng, are very important for Netezza. Now let's go ahead and look at what happens when a host fails. We are talking about multiple hosts here, right? If you remember, I mentioned a couple of times that these two hosts are in a active standby mode. In the sense, I have a primary host, I have a secondary host, but only one is active at any time. So if I make a note here in the notepad one more time, here I have host 1, here I have host 2. Now what I am saying is, when I say df-h, these two will have the same file systems, exact same file systems, right? It's not that file systems only exist here and they are mounted on this. No, it has both file systems exactly same. For example, it has this export home. This also has export home. It has ng. This guy also has ng. Right? Whenever we write anything in these file systems here, whenever we write anything in this export home or ng, so writing in the sense, any block you write, right? Like I said, the minimum IO with the database server or a platform happens in the form of pages or blocks. You know, you cannot write 0.5 KB. Let's say you decided to write 0.5 KB. You know, you can still write it, but still you have to communicate with the operating system or a database server in the form of minimum. The minimum is page or block. Whenever I write something here, the same thing will be written here too. But please note that, don't get confused. It's not like only one file system, right? Host 1 has its own file systems, host 2 has its own file systems. This is like two separate operating systems. Yes, these are two separate operating systems, right? So that's what I'm trying to cover here. And these are not just Red Hat Linux boxes. Red Hat Linux with high availability feature. While installation, you will get an option. You know, when you generally install Red Hat Linux, you have an option to click on high availability. We have two hosts, active, which is also called as primary, standby, which is called as secondary. Each host runs high availability Linux. The Netezza high availability solution uses Linux high availability plus DRBD. DRBD stands for Distributed Replicated Block Device. What I am trying to say here is Netezza high availability was built on platform high availability plus DRBD. What this guy responsible for DRBD? Whenever something gets written on these two file systems, whenever a block, the key thing is a block, whenever a block modified here, the same modification has to happen in the host 2, then only it gets committed. Probably if you are familiar with data guard, it's kind of same thing, right? You know, whatever you write in the primary has to be written in secondary, but in a sync mode here, in the sense whenever host 2 confirms that it's been written here as well, then only host 1 gives you the confirmation. For example, I create a table, create table T1, column 1 integer. Let's say this occupied 2 blocks. Whenever I write here called block 1, block 2, the same 2 blocks has to be written here too. Then only I'll get a confirmation back to me. Only Netezza gives a confirmation to me. You might think that this might be a performance implication because it has to wait for acknowledgement for host 2 as well. Yeah, there is very minor performance implication, but it is worth doing that because we are providing high availability. Is that performance implication notable? I say no, because these two hosts are not very far, right? They are in the same box. They are hardly like maybe an inch different, right? They don't have to travel so much over the network. They both are in the same rack, connected through very super fast, high speed, you know, lines between both of them, right? So it's not like a data guard where we have one in this data center, the other one in a different data center. No, not like that, right? They both are in the same data center. In fact, they both are in the same rack. See what I'm saying? So this is what Netezza implemented, DRBD, on top of Linux high availability. However, this DRBD takes care of only these two partitions, /ng, /export home. Even though I have many file systems and Netezza, like user file system, etc file system, var file system, opt, it only takes care of these two. It only takes care of replication of these two file systems. Along with these two, there is one more directory called ng scratch, right? This is used by Netezza for any host level sort operations. It does not use /temp, right? Netezza appliance maintains a local unmirrored partition on each host named ng scratch. This partition contains temporary files that do not need to survive a failover. So what I am talking about here is there is a directory called ng scratch. This is a directory that Netezza uses for its host level temporary operations. Host level temporary operations. But whatever the temporary stuff happening while host migrates from host 1 to host 2, this does not get replicated. Now how this DRBD works, right? Like I said, whenever a block changes on primary, only on two file systems. What are those two file systems? Export home or ng. Whenever any block changes here, the same change has to be written on standby as well, right? But how DRBD knows that standby is alive, right? Who is watching both primary and standby for its continuous availability? So there is a protocol called heartbeat, right? This, I mean, there is nothing that Netezza written here, man. So these are all important pieces available from platform. They took it and customized it for Netezza needs a little, right? It's the same Red Hat Linux code. They customized it for Netezza needs. The main cluster management daemon in Linux high availability solution is called Heartbeat. Heartbeat watches the host and manages the communication and status checks of services. Now what this guy does is every second this guy pings primary. Buddy, are you alive? Okay, I got a confirmation. It pings again for the next second. Okay, are you alive? Are you alive? So this pings primary host continuously, and if it did not receive any response in like 3 or 4 seconds, it assumes that primary is down and it brings down standby as primary. It's not like active, I mean, it's not like few high availability solutions where human intervention needed. This can happen automatically. You see what I'm saying? Again, again. So this guy heartbeat starts with your Linux automatically. This starts like as a service, and this service's responsibility is monitoring primary and standby. Whenever primary is down, I mean whenever it thinks primary is down, it immediately migrates to standby. Any questions so far? Yes.
So, Ravi, why that, I mean, that DRDB only maintains that NG and export home?
Okay, very good question. Because remaining directories are not going to change. Remaining directories are static. If I talk about /boot, these are the OS level files, right? These are constant across both. I mean, when I talk about, let's say, ls command, I'm not going to change ls command code. Remaining all are only executables are .h files or .c files, or those are the things not going to change. Because these two are the only things that have your data that's going to change with our day-to-day operations. So that is why. Maybe you can say that remaining are static.
Okay. And whatever the, like, for example, create table and the data source, everything that it's stored in NG or NG, right?
It's in ng. Export
Okay.
home is ng's home directory.
Okay.
When I say grep ng from etc password, yes, ng is the user. Export home is ng's home directory. Right. Again, very good question. So please note that this only stores metadata. This /ng, whatever we are talking about, Srinivasa, this is a very important point. Whenever we create a table, the metadata only stores here. Whenever we start inserting the data, the ng hardware has some disks here. Right? We have some disks at a top section, right? So see, we are only talking about middle section so far. We are only talking about middle section. Middle section has this /ng. The middle section only stores metadata. Whenever I start inserting the data into this goes to one of these disks. We'll talk about it. So for understanding purpose at this point, you have two levels of storage here. Not two levels, two different places of storage. One is storage on the top. That's what we learned, where each disk is capable to hold 1 terabyte, right? And on the other side, what we have is we have storage on the host, especially /ng, which is capable to store Netezza's metadata. That means whenever I create a table like this, it goes to host, because create table is a metadata. Whenever I start inserting data into it, this will go and sit in disks, which are also called as data slices on top. We'll get more understanding of this in data distributions class. For now, let's move on. So coming back to this concept here, what we are talking is what happens if a host fails, right? Before we understand that, we are understanding that what are all the various important components that constitute a host. The first one is Linux high availability solution, which comes with the heartbeat service by default, and Netezza implemented DRBD. Linux high availability plus DRBD is called as Netezza high available solution. So this is what I am talking about. So we have another component called heartbeat, right? In a hardware terminology, if you look at these two hosts, the hardware terminology, if you look at these hosts, host 1 and host 2 are in clusters. The English definition for cluster is grouping of similar things. These two are exact same hosts. These two are exact same hosts. They are in a cluster, right? So sometimes you will be confused on which host you are running, whether host 1 is your primary or whether host 2 is your primary, right? It can happen, right? Sometimes, I can say my host 1 name as ngdev1a, and I say host 2 name as ngdev1b. Sometimes you don't know whether you are running on A or running on B, right? If you don't know where you are running, but for application developers, it makes no sense. Whichever is the host you are running, it should be the same interface or same experience. So when you run this CRM underscore resource with hyphen R and hyphen capital W, it will tell you under which host you are running. Similarly, if you want to see which are all part of this cluster and what are all the resources that constitute this entire high availability mechanism, you can simply say CRM underscore mon space minus I5. It will show you all the resources and what are their current statuses. If you just have to manually migrate from active to standby, because you have to apply some patch on active, so you can make active as standby and standby as active by manually running this command. If you want to stop or start any service, you can stop heartbeat. That's not highly recommended. Well, highly not recommended. But if you look at all these options, you have to run as a root. Now this is where the confusion. Who is responsible for my host high availability? Ideally, it's your operating system team. Because we don't know the root password, we don't get the root password because giving root password is a big thing. So a database administrator is not going to get a root password. Why? Because the maintenance of this root password comes under OS responsibility. At max, what you can get is a sudo. If I don't have a root password, how do I manage this cluster and all this? Yes. To be honest with you, the maintenance of this high availability cluster, if any issues happens, is not your responsibility as a DBA. It is a responsibility of your Unix admin. Right? Sometimes what they do is, okay, you guys take care of it. Because this is not like a regular Unix server or Linux server we have. This is a specialized box where both hardware and software has to work very closely. So you guys take care of it. So that's when they say that, okay, I'm making Netezza as a pseudo user. So in worst case, you have to go back to them and tell them that, buddy, it's your responsibility, you take care of it. So they have to work with Netezza support if any issues, right? But this is an important terminology for DBA to understand. So now what constitutes a Netezza resource group? So these two are the file systems. So there are various IP addresses and there is a command called ng in it. So the moment I migrate from primary to standby, it mounts these file systems on the standby box. Right? And it brings up various IP addresses and demands, right, security services and all that. But the important point here is, in summary, the important point for DBA is when a host one fails, it's a downtime. When a host one fails, it's a downtime, right? What we do here is when it is a setup itself, in the etc host file, there will be 5 IP addresses added, right? So one IP for ngdev1a, second IP for ngdev1b, third IP for ODBC IP, which sits on top of both ngdev1a, ngdev1b. This is the IP we share with users. So this is like how do I call, scan IP, right? Which connects to whichever is active. May not be exactly scan IP because scan shares with loads, right? But it's kind of ODBC IP which sits on both of these. It only connects to whichever is active, right? When any downtime on ngdev1a, this IP address will wait to connect to ngdev1b. That's migration from 1a to 1b. When we tested in our lab, it took 3 to 4 minutes. So approximately there is a 5 minutes or 10 minutes downtime, you can publish it to user. You can also manually test this. I mean, just to test the downtime, you don't have to make your primary host die. However, you can manually migrate by running this command. Make sure you have active ETLs and reports run, and you can run this command heartbeat underscore admin.sh hyphen migrate. So then it says that migrating NPS resource group from host 1 to host 2. And that took us 5 minutes. But the important point is what happens to those ETL jobs or reports that are running, right? They have to be restarted. It's a downtime. It's a complete downtime for 5 minutes or 10 minutes. You have to restart. There is no option. That's why Netezza provides high availability. Netezza never committed for continuous availability, right? There is a difference, high availability versus continuous availability. Continuous availability is nothing but they provide 100% uptime, right? So, but high availability is somewhere at 99%. Right. Netezza only gives you high availability. Right. Now you might think that what is going to happen in these 3 to 5 minutes to my user community. This is not a live OLTP system, right? This is not going to face first-hand transactions. All you have in this OLAP environment is second-hand data. That means the data you massage from various systems, you keep it in this OLAP. So it's not going to affect your business pretty huge, right? But it's a big time. I'm not saying no, but just in case your host crashes during a business hours, let's say like uh, on Wednesday morning or Monday morning, these mornings you have pretty huge business, right? And also after lunch, generally US hours are going to be pretty, rush. So let's say at 1:32, it got crashed. Yeah, there is a downtime for 5 minutes. In that 5 minutes, if you are running any micro ETLs or if you are trying to do any dashboards, they will fail. But that's a minimal downtime. But that scenarios are not going to happen pretty frequently, maybe once in like 3 years, 4 years, right? Right. So the first point here to understand, host failure is a downtime. Downtime as in the current ETL jobs or current reports all have to be started again. Now the next point is what happens if a disk fails. The disk I am talking about here is a disk which is sitting on the top. Now what we are going to see in this, if I summarize one more time, is what happens when host fails. These are the two hardware components here we looked at yesterday, right? Disk fails. What happens if an S blade fails? When a host fails, it's a downtime. What happens when a disk fails, right? Before we understand that, let's understand how disk is constituted. Each disk has a disk ID, hardware ID. Now, like we discussed, a disk has three equal parts. If this is 1 terabyte disk, this guy has 1 by 3 of temp, 1 by 3 of user data, 1 by 3 of mirror copy. This mirror copy is user data of some other disk. That means the primary copy of this 1004 is 1001 is mirrored somewhere. That means whenever I write something here, whenever let's say I'm inserting a record here, whenever I'm inserting a record into T1 table and that is coming into this primary portion, the same will be written here too. Then only you get a commit response back. Let's say 1004 is getting mirrored here. Now the main concept of this mirroring is like a RAID 1 model, RAID 1, RAID 1. So when this disk fails, 1004, your query will come and read the data from this mirror copy, right? The mirror disk is selected to be as far away from the primary disk as possible. Mirrors are located on different power supplies. On multiple rack systems, mirrors are not in same rack. Please note that two disks are not mirrors of each other. That means 1004 mirror cannot be here, 1002 mirror cannot be here, because that increases the risk of failure. Let's say if a disk fails here, let's say if 1004 fails, there is no data loss. There is no issue to the current running transactions, because you can come here and read the data, right? But how frequently disks fail? Yeah, these are much frequent than host, maybe once in a year, or like couple of times or 3 times in a year. If your disks are reaching end of life, let's say I bought an appliance now, after 4 years or 5 years the disk reaches end of its life, so maybe that's when you see frequent failures, like once in a month, right? When the system detects that a disk has failed, for example 1004, the mirror handles the failed disk's responsibilities. The mirror copy takes care of these responsibilities until the system has prepared the spare for use. Until system has prepared the spare for you. We haven't spoken on this yet, right? We were talking about in the previous sessions that I have how many disks? Let's say if I talk about a twin fin basic model, I have 96 disks. But out of these 96 disks, only 92 are active disks. There are 4 spares. There are 4 spare disks. Right. Now what are these spare disks going to be there? Why we need spare disks is whenever a disk like 1004 fails, whenever a disk like 1004 fails, the spare will become 1004. That become takes some time. For example, so this is not SPU, this is taken from Mustang environment. So this should be blade. So here, let's say I'm not looking at a temp space here. Let's say this B and D failed. So queries that are coming to this primary partition will be redirected here. That means at any point in time, this disk will handle 2 IOs. So IO will be little slower because it can handle only one at any time. So things coming to read E here, things coming to read B, both will get queued. There is this little slowdown for those 4-5 minutes till this pair gets regenerated, right? So that means whenever this disk fails, system automatically redirects, the host automatically redirects the queries coming to read this partition B here. That's nice. Now what happens simultaneously is you have a spare, right? The spare will get regenerated exactly as B and D. Now from where it is getting B and D partitions? The B partition is already here, the D partition is already here. So it just has to copy them both from here to here. Now this process is automatic. You don't have to do anything. All you have to be responsible as infrastructure DBA here is make sure your system has sufficient space within it. Right, we are talking about here, right? I have 92 disks active, 4 spares, right? So make sure you always have 4 spares. Let's say if 2 disks fail, you never know, right, when a disk fails, when worst of the worst cases, just to make sure you have all the 4 spares all the time. If a disk fails, your responsibility starts there. If a disk fails, the disk will show as a green, red color in the monitoring system. It's your responsibility to work with your client and your IBM support, your local teams, change control teams, and data center teams to replace this disk. I'll talk in a separate class on how to replace this disk, the standard steps to follow, but your primary job here is coordination, right? Make sure someone walks into the data center and pulls out this disk and put a new one. One important thing to notice, the disk replacement here is a hot swappable activity. Means you don't need any downtime. If you want to replace this failed disk, it's as equivalent as just pulling it out and putting a new one. While that is happening, your normal operation continues. So in summary, what I am talking about here is a disk failures is no downtime, zero data loss, zero downtime. Any questions on this so far? Host plus disk. Yes, right.
So Ravi, what if consider a worst scenario like where since it is only RAID one, so what if two disks fails? I mean, whatever the even the mirror copy also like we lose. Uh, I mean, what happens that time? We're gonna lose the data, right? Basically.
Yes, if two disks, for example here, if I go back, if 1001 and 1002 failed at the same time,
Mhm.
exact same time, maybe 5-10 seconds here and there, then you have a data loss. Agree. However, however, those chances are very less, right?
Okay.
Those chances are very less because the regeneration of 1001, let's say if this disk failed,
Mhm.
making spare exactly look like this, it will take like 2 minutes or 3 minutes.
Okay.
So if you have also the failure of mirror copy in the 2-3 minutes, I mean it's your worst case scenario. That's why you have DBS.
Okay.
That's still possible, but the chance
Yeah.
probability is very less, very less. Because it's only a matter of 2 minutes or 3 minutes where the spare becomes active. First of all, failure of disk is a remote activity like once in a year,
Mhm. Okay.
right? So yes, to answer your question, yes. So that's why we regularly take backups
Okay.
and you have to go back to your restore mechanism. There is no other option.
I think in Teradata it's a RAID 3, I suppose. I don't remember exactly, but RAID 3, I guess.
And even there also it's a possibility, right? What if 4 or 5 disks which belong to the mirror copies fail at the same time, right?
Yeah.
There is a chance, there is a chance, but that's why we put it back. But have I seen such scenario in my past 6-7 years? I say no.
Okay.
Unless
Mhm.
you also have a capacity to manually fail these disks.
Mhm. Okay.
Right. Okay. Right. Now, moving on. The third point. What happens if a S-blade fails? Now, to understand this, let me walk you to the day one presentation. There is one slide here. What happens when a S-blade fails? When this S-blade fails, like we discussed yesterday, each S-blade has a set of disks associated with it. Each S-blade has a set of disks associated with it. Now when this S-blade fails, host has to come into picture and host has to take these disks and host has to assign or balance these disks across rest of the S-blades. This reminds me a scenario where one of my project teammates left recently and his work we need to load, we need to share. Right? Let's say we are like 20-member team, if a person leaves, the remaining 19 people has to share the load till a replacement joins. See my point? It's exactly the same scenario here. This S-blade is responsible for 8 disks, let's say here. Those 8 disks will be balanced across remaining blade servers till we replace this. Now, this replacement process, not replacement process, this assignment process of these disks to remaining causes a downtime. There is a downtime, right? System will go through various stages because the topology initially decided by Netezza system that okay, I'll assign these three disks to this guy, these three here, these three here. Now we are talking about redistribution of a disks across existing blade servers. So there is a downtime. And the downtime is between like 3 minutes, 4 minutes, 5 minutes, right? It just has to bring the system to a paused state and realign this and bring it back system to an online state. Right? We haven't spoken on this paused state yet, right? But there's a downtime. Now, in summary, what I'm saying here is, yes, that's a downtime. But the important point to note here is the frequency. How frequently these happen? So host failure, I haven't seen it one, but I have heard one of my friends uh, go through this in a production. I'm talking about in production, okay? So disk failures, it's quite common. Maybe, if you have like 4, 5 Netezza systems, it's quite common. You handle one disk failure at least once a month. No, something or other thing you work on disk failures. Blade failures, it's again very rare. Blade server, right? It's not as catastrophic as a host failure, but still possible. And it happens on the same frequency, like once in like 2 years, 3 years. So whichever is running at that time will be terminated. You just have to resubmit them. These are all the three major hardware components we should be focusing on. And our responsibility as a DBA is to make sure these are replaced if it failed as soon as possible. Like that. Right. Any questions on this, Srinivasa? You got any questions so far?
No, no, Ravi. I'm
So the log file information is stored here. All Netezza standard logs are here. All Linux standard logs are here. So we have a separate class on Netezza log files. But for now, all the Netezza log files, like alert log in Oracle, instead of maintaining a single log here, each major component has its own log. For example, backups will have its own log files, restores have its own log files, incoming connections has its own log files, right? Like that. But let me take a minute break before I start this. Just let me take a 1 minute, quick minute. Right, I'm back. So let's start. What I'll be talking about next 30 to 45 minutes is how Netezza environment is going to look like. Like what we are going to do, basic things once we get into Netezza environment. Right. So as a DBA, you will have an IP address where your Netezza server is running. And the moment you open an IP address, it will ask you to say enter your user ID password. Sometimes you have NG user, sometimes you don't. You log in with your user ID and you sudo to that NG user, right? Whatever that is, you have to be in NG at the end, right? So the environment, so if I say uname -a, this is a Linux box. This is a Red Hat Linux box, 64-bit operating system. Right. So the environment is like, if you look at the default shell is bash. Right. So by default, you have various environment variables set for easy working here. So few notable environment variables are ng_database, the default database. This is ng_host is your local host, ng_user, the default database user, the default database is password. These are setted in your bash profile. These are setted through this bash profile. If you look at this cat.bashrc, through here it is setted. So this is the environment. So if you walk you through this, somewhere you will find that environment setted. Right. Now, if you look at working in Netezza environment for a DBA, is mostly through command line interface. If you look at what, the same command line interface I'm talking about here, hit a dollar, right, like NGHW, right, will show list of hardware, ng state. This is a command line interface I'm talking about, right. Most of the work in Netezza is through command interfaces only. So if you look at, each command has a bunch of options as well. If you would like to understand those bunch of options, you have to say command name followed by -h. You have to say command name followed by -h. It will show you help. So when I'm just saying ng state, it is saying system state is online. But however, this command ng state has further sub options such as show, wait for, list states. Show, wait for, list states. When I say ng state -hc, list states here. -hc will show me how to use these options. These are like Unix or Linux commands, right? You have uname. When I say uname, it shows complete information. Sorry. Uname -a, it shows complete information. When I say uname -a, it shows only node name. It is host name. The similar way, you have bunch of options here. ng state has bunch of subcommands within it. If you want to have an information about this subcommand, ng state -sc, list states. So when I run this command, it will show what are all the states, high level states my Netezza system can be in. So this is very useful here. It's not like other environments. The complete help of a command or options is inbuilt, right? You don't have to Google or refer manuals for commands help. Here if you look at ng state, list states will tell you these are all the states your system is in. Now let me take a minute to help you understand what are all these states meant by. Okay. So system state, current queries, incoming queries, right? When system is in online, current running queries will proceed, incoming queries are accepted. When system is in stopped, current running queries, no current running queries, because system is stopped, incoming queries are rejected. So the command to take your system to online state is ng start. The command to take system to stopped state is ng stop. Stop is nothing but your software is not running, that's it. Stop is nothing but your software is just not running. You see what I'm saying? Now there are some intermediate states, online to stopped. So there is a state called paused. When I say paused, the command to say it is, I say that ng system pause. When I run this command on an active system, so let's say if my system is actively processing like 100 transactions, and all of a sudden when I run this as a DBA, the current running queries will complete. Incoming queries will be queued. I might have to pause my system. It's like pause. It's like when you are watching a movie, just pause it, right? So it's not. It's just going to stop there, right? It's not going to put you when you are going to resume it. It's not going to ask you to start from first minute again. No, you are going to start from wherever you paused. Current running queries will complete, but incoming queries will be queued. So on what scenarios we pause it? Let's say when you want to change some configuration parameter. So to change configuration parameters, here you don't have to take a downtime. Like whether it's a static parameter or a dynamic parameter, pause is good enough. Pause is good enough. So like P file or SP file, the pose configuration parameters here can be changed in a paused state. There is an option again here called paused now. This is ng system pause -now. When I want to pause right away, current running queries will terminate. Incoming queries will be queued. There is other equivalent state called offline, but current running queries will complete. Incoming queries will be rejected. On what scenarios we go for online? ng system offline. Maybe you want to apply a patch. Right? Such kind of scenarios. So see, even offline has something called offline now. Will terminate current running queries. Incoming queries will be rejected. So there is one worse scenario called down. So no current running queries, no incoming accepts. This is worst scenario. Why this is worst scenario? Your Netezza system will be in a down state only when any major hardware component is gone. Such as you have, the scenario that Srini was talking about. 2 disks failed, which are mirror copies for each other. Like 1001 disk failed and the mirror copy where 1001 is exists also failed. Then you cannot run your system. It's a major scenario. It's a down, right? So in summary, these are all the high level states. Sometimes you see a state called discovering. It means it's trying to discover all hardware components. Then initializing. So it initializes all components. So these are intermediate states, various intermediate states. But these are all the major states we should be aware of. And the associated commands. ng start, ng stop, and to go to intermediate stages you have ng system pause. If I show you that one ng state, when I say ng system -h, ng system has two major purposes. One is to take system to intermediate stages. Second one is to change configuration parameters. So when I say ng system pause, it will ask me that are you sure you want to pause your system? Say yes. The system is in a paused state now. So if I want to resume, say ng system resume. The system will come back to online state. When I run this ng state, the system is back online. Like this you have bunch of commands. All these commands when you say ng state are available in ngkit bin direct. They are all available in ngkit bin direct. So if I take you there, you know we already looked at ng hardware. When I say ng stats, it tells you quick information about your system. It tells about quick information about. So we'll slowly look at most of these commands. So not this replication and these guys, right? But majority of the commands like ng load, backup and restore, ng event. So these are very easy commands. There is an important command here that is called NZSQL that we are going to look at right now, right? Right. But with using all these commands, what I can do is I can interact with hardware, I can interact with databases, I can interact with software, right? So out of all these, the one command that we as well as developers use most frequently is NZSQL. When I say NZSQL and enter,
Ravi, I have a question, Ravi.
go ahead, Srinivas.
When you type NZ, NZ host, there is a host name, IP address, right? That IP address belongs to primary or standby IP address?
Right, that's a good question. Here I cannot show you primary or standby, but in a real environment it points to primary host always, whichever is the primary.
Okay, understood. Got it.
Right. All right. Okay. So now the important command here we have is NZSQL. What happens when I run NZSQL is it takes you to an interface where you have an option to talk to databases. So this is an input we got, output we got whenever we typed NGSQL. Welcome to NGSQL, the Netezza SQL interactive terminal. It's saying that type \h for help with SQL commands, \question mark or internal slash commands, \g and \q. When I say \q, it will come back to the dollar prompt, right? If I type NGSQL again, it will show me a prompt where three different words, three words are notable here. The first one is database name, second one is schema name, third one is username. For people coming from Oracle background, the important difference here is under Netezza instance, I can have multiple databases created. I can have multiple databases created. For example, when you log into NZSQL in your environment and you type \l, you will see system and test databases, right? So these are all the other databases that I have created through various channels. So system is a default database. Probably you can think it of as a system table space, right? It holds all the system metadata. Okay. So \l is a command that will help me to get this information. Now what is these / commands? These are aliases for most of the commonly used SQL. This is not like a NoSQL database, kind of an interface where you don't have to majorly write an SQL for commonly administered tasks. Right. \l is one such option. It will go and get the information of what are all the databases and who are the owners. Now, if you want to connect to other database, \c, I just have to say, let's say testdb1 as a user admin, and the password of admin is password. Now \c is to connect or switch between different databases. Now I have moved to testdb1 database here as a user admin and password as password. Now if I want to see what are all the list of tables this guy has under this schema, I have to say \dt. I have to say \dt. \dt will display the tables of this user within this schema. Now another important difference you need to note is it's not a single schema and single user. In Oracle is one user equals to one schema, right? But here one important feature Netezza added from 7.0.3 is single user can have multiple single instance, multiple database model. The second one is single user can have multiple schemas. So in Oracle is one user equals to one schema, right? Here one user can have multiple schemas. For example, Srini is a user. By default, Srini can have Srini schema, schema 2, schema 3, schema 4, like that. N number of schemas Srini can have. So Srini can have Srini.t1, schema 1.t1, schema 2.t1, schema 3.t1, like this. The same object he can have it in different schemas, right? This is another important difference from Oracle. So those kind of things that I'm trying to explain you here. Right. So far we have tried logging into NZSQL just by typing NZSQL. At any point in time, if you don't like, just quit from here. Backslash Q. Backslash Q. So when you say NZSQL again, you will log back. Now, the question we must ask ourselves is why it is always connecting to system database? Why it is always connecting to admin user and admin schema? That is because we have specified them in our environment. When I change this export ng underscore database to testdb1, and if I run this NZSQL, this time I connect to testdb1 database, right? If you don't like that, so you can pass these arguments as, you can pass this information as an argument. This time I want to connect to test database. So the priority is it first checks for command line arguments, then it goes and checks in environment variables. Any questions so far?
No, Ravi.
Okay. Now, the important thing to note here is these backslash commands. When I say backslash question mark, it will show you list of all the backslash commands available. So when I say backslash dt, it is showing me list of tables, right? When I say backslash d, t1, it will describe the table. Like DESC is a command in Oracle, right? Backslash d will describe the table. Backslash du will show the list of users available. Backslash ACT will show list of active sessions in the system. For most commonly written SQL, there are bunch of backslash commands. These are just nothing but an aliases. These indirectly call the same query in the backend, right? Now, the important thing to note here is at least it is recommended to practice these backslash commands at least once. At least once. So just see what each one does. What happens when I say backslash dy? Just read these ones. What happens when I say backslash ds? All these information. When I say backslash dt, it displays all the data types available to me. All the data types Netezza offers. Right. So, but normal SQL, still you have to write it. There is no option. Select start from T1. You cannot put that in a aliases here. You still have to write the same select statement or DML or DDL statements. Right. But the one beauty here is, why is taking time? Yeah, it's going to talk to storage here. That's taking some time. The beauty here is, when you say NZSQL capital E option, I'm not just typing NZSQL, I'm typing with an option called -E. Now this is an important option to watch out for. Now this command will show debug information, such as what are all the commands the system is running in the backend to generate the data. When I say \L, you are getting the output here. You are getting the output here. But what is the query it is running in the backend to get the output? What is the query it is running in the backend to get the output? So this is the query it is running. If you want to understand what are these _v, these are like the same $v views. Now you just describe it, and these are all the queries it ran in the backend to generate the describe. If you look at this _v_ database is a view, which is built on top of underscore T underscore database. Underscore T is a physical table. So these are the very good starting places to understand internals if you are really looking at deeper, right? So now when I say select count star from underscore T underscore database, I see 11 databases. When I say select count star from underscore V underscore database, I see only 10 here. Now there is one database extra which is not visible by default. Is called master underscore DB. In older releases they used to show this, but this master underscore DB is no longer coming by default because it's just a template database. Let's say whenever I create a database like this, the simplest way of creating a database is create database name. You don't have to specify temp files, you don't have to specify redo logs, transaction logs, default table spaces, users, nothing. Simple create database name. If you want to look at this syntax, \h and create database. I'm saying create database name. The maximum you can specify is like character set. This collect history on that we'll talk about in query history replication. So the basic syntax is very simple. Create database name. When you do \L, it will show you the newly created database. When you say select current user, it will show you what is the current user you logged in as, admin. So that admin created Srini. But the database creation is very fast here because it just has to copy master underscore DB template to this new database. Because a single instance can have multiple databases, so they are maintaining kind of a template database. In older releases, they used to show this under \L, but now they are not showing it because it's of no sense. Right? It's just like a static there, right? But anyway, the important point here is not understanding only master underscore DB, but also understanding the architecture here. Underscore V database, underscore T database. How do you get help when you say \h create? Synonym, let's say for that matter. How do you create a synonym? Right? So there are a bunch of / commands designed here for your easy administration. Similarly, there are a bunch of options your NZSQL can log in with. When you say NZSQL space -h, NZSQL also has bunch of external options. Right? We have used only one option called -e. Of course, we have used other option like -db database name. Right? You can also use -u username. Right? These guys. Right? You see what we are doing? That's what I try to put it in these slides here. What happens when you use these important options? What happens when I start NZSQL with -A? What happens if I use it with small a? How to use \I option? Right? What if I have to just run a single query? If I have to just run a single query, for example, NZSQL -db system -user admin -password, I can simply run a single query as select star from T1. Select star from T1. So I don't literally have to log into that environment, connect to it, then only run this. If I have a simple one query to run, right? Let's say if I have a file where I have to run this script, I just have to say NZSQL -dp system -user admin -password from file, take input from file, right? So sometimes during the production promotions you have to run only SQL scripts rather than you run manually. So what I am asking you is to experience these options. Try it out. If you have any confusion, we can discuss it in next class. And also once you log into NZSQL, you have a bunch of / commands. So, where is question mark? Yes. / ? Similarly, you have when you say / and enter, you see list of SQL commands that you can type. Help of any command, just say / create table. This is a create table syntax, right? Like I said, / ? /h NZSQL -h. Three different things you need to practice. I try to put the basic ones here, few just to start with. So you can just practice them, or you can go beyond them to see what happens when you use one of these, right? So this would be very helpful whether you are a DBA or a developer. This has to be practiced as long as your work requests you to work in NZSQL prompt. That's pretty much I have for this session. Understanding default user accounts, understanding high availability architecture, NZSQL introduction. In the next session, what we are going to talk about is how do I create various database objects? How do you create a database? We quickly looked at database creation today, but we look at in detail how do you create a table. Then we proceed from here, what are all the data types available in Netezza, right? So then views, material views, user management. That's going to take tomorrow and day after tomorrow. Any questions so far? Probably any questions for now? Go ahead.
No, Ravi, probably we practice maybe in case of any queries, we'll get back to you.